What if there's something more fundamental in nature than the very own laws of physics? They can explain these exotic new phenomena called time crystals. And what if that something is so simple, it has been right in front of you the whole time? Worry not, because I'm about to give you a symmetrical picture. When we try to describe our universe, symmetry simplifies our understanding. For example, when defining a sphere, my awesome dog, or cube, we can say, except for my dog, that they're symmetric under rotations. Symmetric means that I can make a transformation of any kind, in this case rotate, such that when I look back, there is no difference. However, the sun can be rotated by any angle, it's a continuous symmetry, but a cube can only be rotated by multiples of 90 degrees, it's a discrete symmetry. Not only oranges are symmetric, its particles are too. I could swap every electron of the universe for another electron and couldn't say which particle is where. Thus, all the particles of the same kind are exactly the same. Particles interact by the four fundamental forces, yet these two arise from a special type of symmetry. Consider a collection of boats, such that each boat is free to define where its geographical north is. We can change the north direction for each boat differently, and it doesn't matter. Therefore, we have a local symmetry. But for us to compare each boat, we need something that permeates the whole universe to tell us the different directions at different points. In the boat case, this would be the underlying sea, and sea waves would carry force. Just like the electromagnetic field that carries a force and makes like charges repel, or different charges attract. Space-time itself is symmetric. If I change my position in space, or rotate, or change my position in time, the laws of physics remain unchanged. But there is more. Galileo said that the laws of physics behave equally if you transform from an observer at rest to another traveling at a constant velocity. But he assumed time passed the same way for both observers. Wrong. We live in 4 dimensions, but let us merge the 3 spatial dimensions into one, so we have a simple 2D graph. Now, because of symmetry, no matter how fast an object is moving through space, its velocity in space-time, the magnitude of the arrow, remains the same, and so if it moves more in space, it will move less in time. Hence, we get time dilation, and that's why light, which moves at the maximum velocity in space, moves at no velocity in time, and its clock marks 0. Anyway, as much as symmetry is fundamental, symmetry break is more, and distinguishes different phases of matter. Water is spatially symmetric, but ice is not. It breaks that symmetry. Although both are in equilibrium, they are not intrinsically changing in time. If I heat a piece of ice, it melts, but it is not changing. It is just transitioning to a new phase. However, in 2017, it was discovered the first example of a non-equilibrium state of matter, time crystals. The same way spatial crystals have a periodic arrangement in space, thus breaking continuous space symmetry, time crystals have a periodic arrangement not in space, but in time. They are created by pulsing an array of atoms with a laser that, together with disorder and magnetic interactions, is able to rotate them to the original position at twice the pulse period, creating a robust structure that repeats itself forever and doesn't change even when we vary the laser frequency by a small amount, thus breaking the laser's discrete time symmetry. 3 minutes have passed, and because the world is beautiful and symmetric, we can now proudly physically state that the laws of physics remain unchanged.